So for this one that's been up here, how would I find the length of GF? GF goes from here to here. You know, that is the radius. Yeah, O is the center. You know, that's 3, so GF has to be, careful, GF has to be 6, double that. No, GF is 6. If I ask you to find angle EDA, EDA is right here. Well, let's label what we know here. We know GE is 120 degrees. DA here, 70 degrees. ACF, where's C? ACF is this right here, is 30 degrees. OG is 3. We said no, this is perpendicular here. And 2.5 is EK. So EDA, well, how does any of this help us? Well, we know that this angle right here has to be what? Look at that yellow figure that I highlighted. It's a 4-sided figure, right? You know this is a right angle. You know that's a right angle. 4-sided figure has an angle sum of 360. Minus 90 is 270. Minus another 90 is 180. Minus 30, 150. So this is 150 here. If that's 150, what's this angle right here? 30. Which makes this arc here 30 degrees, correct? So now back to angle ADE. It intercepts this arc right here. How big is that arc? 150. 30 plus 120 is 150. That angle, is it equal to 150?
No.
Say no.
No.
It's half of it. Because it's inscribed. If it were at the center, it would be equal to the arc. If it's inscribed, the vertex is on the circle, it's half the arc. Sound familiar? Angle EHF. EH, where's F? Right here. This angle, right here. Will be the same as this angle. We know that this arc, of course, is how big? 170 plus 30, right? 100 degrees. Do we know this arc right here? Well, this is a diameter, right? So that side has to be 180. So that's 120 minus 180, that's 60 degrees. So what we have is we have that arc, or that angle, intercepts an arc, it's an average of 100 to 160. 100 plus 60 divided by 2 is going to be 80 degrees. Next, if I ask you to find the circumference of the circle, it's going to be pi times 6 centimeters, otherwise known as 18.84 centimeters. If I ask you to find arc, ADF, ADF, that's going around this way right here. That one's going to be an easy one. Yeah, you have to subtract, it's 180 degrees for half the circle. Subtract 30 gives you 150. So if I ask you to find arc EF, but notice on 5 I asked for degrees. Here I ask for centimeters. I want its length. EF we know is 60 degrees. You got a circumference of 18.84 times 60 over 360, which is going to give us 3.14, right? Centimeters. Area of sector GOA. Sector GOA is this one right here. How do I find its area? Well, it's 30 degrees, right? We're going to find the area of the whole circle, which is going to be pi times 3 squared. Radius is 3, right? So 3.14 times 3 squared is the area of the whole circle. 28.26. Then we're going to take that times 30 over 360. .355 centimeters squared. Any questions so far? Angle OFC. Bless you. So here's O, here's F, here's C. So we're looking at this angle right here. Better be 90 degrees, yes. KJ. KJ is from here to here. What's that? Well, we know the DK is 2.5, right? So KJ better be 2.5. Angle ABD. ABD, that's this angle right here. We know this out here is 150. We know this in here is 70. Since that's an exterior angle, it's 150 minus 70 over 2, which will give us 40 degrees if we calculate that out. And I'm not going to confuse you with KF. Anybody really want to see how to find KF?
Yeah. I tried figuring it out last night.
Okay, KF is this piece right here, right? We know that GF is 6. So if I let KF equals X, right? GK is equal to 6 minus X, right? And we know that EK is 2.5, and we know that KJ is 2.5. So let me draw what we have here. We know the diameter is 6, and this is the diameter. So if this here is X, this is 6 minus X, like I just said. You were given that this is 2.5, so this is also 2.5. So what we have is 2.5 times 2.5 has to equal x times 6 minus x. Remember, we talked about that. You multiply the pieces of the chords. 2.5 times 2.5 is 6.25. X times 6 is 6x. X times negative x is negative x squared. This is what's called a quadratic equation. To solve it, I have to move everything over to the same side. This is a negative x, so I'm going to move it over to the other side to make it a positive x squared. So I'm going to add x squared to both sides. I'm going to subtract 6x. So what I have over here is x squared minus 6x plus 6.25 equals 0. I now need to solve this. I could factor, I could complete the square, or I'm going to show you there's a really fun formula for this. X is equal to, where A is the number multiplying the x squared, which in this case would be 1. Where B is the number multiplying the x, in this case that's a negative 6. And C is the number all by itself, in this case 6.25. The value of x is equal to opposite of b plus the square root of b squared minus 4ac over 2a. Or x is equal to opposite b minus the square root of b squared minus 4ac all over 2a. Did you?
Yeah, I remember that. Oh my gosh.
So we're going to put in the opposite of b. B is negative 6. The opposite of b is positive 6. I'll put it into both formulas at once. In the square root, b squared, negative 6 squared is 36. So I'll put that into both of them. Minus 4 times a times c. Well, 4 times 1 is 1. 4 times 1 is 4, sorry. Then 4 times 6.25 is 25. So it's 36 minus 25. That's going to be over 2 times a. Well, a is 1, so that's just going to be over 2. 36 minus 25 is 11. So then we got to do the square root of 11. .3166. So those are the two possibilities. So we're going to start with this one over here. We're going to go 6 plus that equals, and then we're going to divide by 2. So that's 4.658, it looks like. Then we're going to try this one over here. 6 minus 3.3166 divided by 2 is 1.342. Well, can it possibly be 4.6?
No.
No, that's got to be less than the radius. The radius from here to here is 3, so it can't be bigger than the radius. So the answer would have to be the 1.342. What do you think? Better than a sharp stick in the eye?
It's all coming back to me.
Well, that could... So now let's take a peek at this. Should be mostly review for us. Let's say we have a circle with a radius of 8 inches. In your notes, quick, find the area of that circle for me.
length or is it pi length? No, it tastes like a lot of erasers. Pi times the diameter circumference. Oh my God, I'm so proud of you. Algebra?
Alright, figure the correct face. I could go hunting this freaking thing. You ever think about doing that, Todd? Putting an equation out of stuff?
So it's going to be pi times what?
Radius squared.
Radius squared. What's it come out to be?
201.06. Let me say 102. 102.
Basically 201 inches squared, right? If you use 3.14 for pi, it's 200.96.
Or you can just simplify and say it's 64 pi.
You think you're funny.
I'm being.
We have a central angle of pi over 3 radians. Find the arc length. I'm going to pause and let you look at this.
Yeah, I think
Okay, there's a couple ways you can approach this. One is, of course, pi over 3 radians is 60 degrees if you do the conversion. If you're going to do it that way, the circumference is 16 pi, otherwise known as 50.24 inches. So you'd find that arc length then as your circumference, 50.24 times 60 over 360. Otherwise known as what? 8.37 about inches. The beauty of radian measure. Pi over 3 radians times 8. The interior angle, or the central angle, is pi over 3 radians. If I multiply that angle by the radius, so 3.14 divided by 3 times 8, guess what I get? 8.37. That is the strength of radian measure, is to find an arc length. All you have to do is multiply that central angle in radians by the radius. So, next question. Find the area of that sector. Here, I'll scroll back up so you can see it. So, the question is there a shortcut for using the radian angle for sector area? So the area of the whole circle is what? .201, right? So the area of the sector is 201. We're using it as degrees, it's 60 over 360, which is going to be 35 point. $37 exactly, isn't it? No. 33.51? Yeah, that's what I'm sure. 33.5 inches squared. That's really the only way to do it. If you wanted to use the radians, take 201 pi over 3 over 2 pi. The pi's will cancel out. So what you have is 1/3. So this is 201 times 1/3 over 2. So 201 times 1/3 divided by 2. 33.5. So there isn't a simpler way of doing it with the radians, other than canceling out the pi's. Now let's have some fun. Still 8 inches. This is still a pi over 3, but I'm just going to label this 60 degrees. I'm going to cut this across here. How long is that cord? How do you know it's 8 inches? If this is 60 degrees, right? These two are the same, which means these two angles have to be the same. 180 minus 60 leaves you with 120. Divided by 2 gives each of those 60 degrees. So since all the angles are 60 degrees, all the sides have to be the same. I want you to find the area of that segment for me. I will pause for you. So you already know the area of the sector is 33.5, right? What do you need to know? The area of the triangle. How do you find the area of the triangle? We don't have a height. You can make a height. You can cut it here. Knowing that cuts it in half. This is 4 and this is 8. You can do a squared plus b squared equals c squared. Or, for those of you from last semester might remember Hero's formula. Hero's formula says you have to find the perimeter, which would be 24, right? That's just adding up the sides, 8 plus 8 plus 8. Then you find the semi-perimeter. We divide by 2 gives you 12 inches for the semi-perimeter. So then, area, remember, is equal to semi-perimeter times semi-perimeter minus side A times semi-perimeter minus side B times semi-perimeter minus side C. So that would be the square root of 12 times 12 minus 8 times 12 minus 8 times 12 minus 8. Otherwise known as the square root of 12 times 27.71, correct? Or you could have done, since this is equilateral, you know that this has to be the square root of 8 squared minus 4 squared. Which is a 6.93. So this would be that times the base of 8 divided by 2, which will also give us 27.7128. 27.71. So that is 33.5 square inches minus 27.71 square inches. So what do we have there? 5.79 square inches is what I'm getting. Everybody come up with that? What do you think, Tate? You look confused. Baffled? Bamboozled?
He's amazed.
Hopeless? Overwhelmed?
Step 1.
Step 1, call a professional. Page 595 in the book, exercise 27-3, 1 through 19 there. Page 597, exercise 27-4, 1 through 9 there. Reviewing circles and arcs and sectors and segments. Oh my. And of course, you need to finish up your quizzes if you haven't yet. Looks like most of you got it in already.